Applications of integration, page 5, number 15. The shaded area is 1 unit. Find B correct to 4 decimal places. Okay, so let's write out the integral that we're going to do here. It's going to be the integral from 0 to b of the function square root of x dx. And they said that that is equal to 1. And so let's take the integral. It's actually x to the square root of x is actually x to the 1/2. If I take the integral of that, it's going to be x to the 3/2. 2/3. And then I'm going to evaluate that from b to 0. So if I put b in there first, it's going to be 2/3 b to the 3/2. And if I subtract this with 0 plugged in, it's just going to be 0. So if I set that equal to 1, which is the area of this, which is the area of that shaded region, let's see, I'm going to do algebra now. I'm going to multiply both sides by 3/2. So I'll have b to the 3/2 is equal to 3/2. And then I'm going to take the 2/3 root of both sides, so it's going to be b equals 3/2 2/3 root. Okay, so that's our answer. That wasn't too bad. 19C, kinematics. Write the integral that calculates the area under the velocity curve. This is the velocity curve. Which also finds the distance traveled. Okay, same way we did it before. We're going to integrate from t1 to t2, which is the initial time to the final time, and the function is just the velocity function, and now we're integrating over time. 19C1. A runner has the velocity time graph shown. Find the total distance traveled by the runner. Now remember, the integration under the velocity curve, the area under the velocity curve, actually gives you the distance traveled. Just like whenever you take the derivative of distance, you take the derivative of distance, you get velocity. You take the derivative of velocity, you get acceleration. If you take the integral of acceleration, you get velocity. If you take the integral of velocity, you get displacement. So if you take the integral of the velocity curve, you're going to get displacement. So the total distance run is just going to be this area that's underneath the curve. And since this area is conveniently drawn with a bunch of triangles and trapezoids and squares or rectangles, we can actually figure it out exactly. So for example, this region here is all rectangles. This is rectangles. So in here we have 7 rectangles. So we have 7 rectangles here. And then we have triangles. I'm going to make the triangles in purple. So we got half of 3. We got half of 4. And we got half of 1, so that's half of 8. So actually we got 4 rectangles that are purple, right? Because we have 8 half ones. And then we got 7 green ones. So in all we have 11 rectangles. Each rectangle is 5 seconds across, and it's 2 meters per second tall. So each one has an area of 10. Okay? So we add these up, we get 11 rectangles. 11 rectangles times 10 meters is equal to 110 meters. Okay. the reason why we got 10 here is it's because it's 2 meters per second times 5 seconds. You can see the seconds actually cancel out, and you end up with 10 meters. Okay. Number 3. A cyclist rides off from rest, accelerating at a constant rate for 3 minutes until she reaches 40. Okay, so what would that look like? It would look like starting at 0, because it rides off from rest. Rest is 0. Accelerating at a constant rate for 3 minutes until she reaches 40 kilometers an hour. So it would look kind of like this, I think. 40. And then that would be in 3 minutes. She then maintains a constant speed for 4 minutes until she reaches a hill, until reaching a hill. So this would be the 7-minute mark because she continues for 4 minutes at a constant speed. And then it says she slows down at a constant rate over 1 minute to 30. Oops, and I just ran out of space, so let me shrink this down a little bit. Maybe we'll put it down here. Okay. Okay. So then she slows down at a constant rate for 1 minute. So that would be to the 8-minute mark. And then to 30 kilometers an hour, which would be about here. 30. And then continues at this rate for 10 minutes, so that would be the 18-minute mark. And then at the top of the hill, she reduces her speed uniformly and is stationary 2 minutes later, so that would be the 20-minute mark. Okay. I think that's right? So starts at 0, accelerates constant rate for 3 minutes until she reaches 40. That's 40. She slows down a constant rate over 1 minute, or she maintains that speed for 4 minutes. She slows down a constant rate for 1 minute to 30. And then continues at this rate for 10. That would be 18 minutes. And then at the top of the hill, she reduces her speed uniformly and stationary 2 minutes later. So, yes. Okay. Draw a graph to show the cyclist's motion. There it is. How far has the cyclist traveled? Okay, so let's do the same thing we did before. This rectangle regions we'll draw with green. And then the triangular regions, actually we have another rectangular region like kind of there. And then the triangular regions we'll draw in purple. So that's a triangle, and that's a triangle. So the green region, let's see, we got this region, it's 4 by 40, which is 160. This region is 1 by 30, so it's 30. And then this region is 10 by 30, so it's 300. So the green part is 160 plus 30 plus 330, which is 190, 490. So the green part is 490. And then the purple part, let's see. We got this first part, which is 3 by 40, which is 120, but it's half of that, so it's 60. We got this part here, which is a height of 10 and a width of 1. So it would be 10 divided by 5 is divided by 2 is 5. And then we got this part, which is width 2, height 30. So it's 60 divided by 2 is 30. So the purple part we got 60 plus 5 plus 30, which would be 95. And then we can add those two together to get the total area. Be 585. So he traveled 585 kilometers. Ooh, but one thing. Each one of these blocks, let's look at a block. So one block is 1 minute wide. Right? And it is 30, or each block is 1 kilometer per hour tall. So these are not the right, these are not the same units. So each one of these blocks, which I thought was 1 by 1, is actually like 1 kilometer per hour is actually 1 kilometer per 60 minutes. So the area of one of these blocks is actually 1 divided by 60. So the area of 585 blocks, you actually have to multiply it times 1 over 60, and that would give us kilometers per, that would give us kilometers. Right? Okay, so 585 divided by 60 is, I'll do that on the offline calculator, 9.75. So he traveled 9.75 kilometers. Okay? And that's it for page 5.